Hi everybody, Mr. Murray here. I'm sorry that I can't be with you today, but I thought I'd make this video for you so at least you get the lesson and you have some understanding of what's happening so that you can get to your homework tonight. So the first thing I want to do with you for this lesson to begin counting outcomes using or with probability, I should say, is to create a tree diagram. Now we've already done this, so this is not new to you. I want you to find in example 1 the probability of tossing exactly 2 heads when a coin is tossed 3 times. And if we're going to draw that tree diagram, it's the exact same as the one we used before. The first flip is either a head or a tail. Second flip, head or tail, head or tail. Third flip, head, tail, head, tail, head, tail, head, or tail. And we notice that there are a total of 8 outcomes here. You can start listing them: head, 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 tail, etc. I'm just going to put dot, dot, dot. I'm not going to list them all. We've already done this once. Now, out of all of these, how many of these outcomes have exactly 2 heads in them? Well, let's list them. The sample space is every outcome. And I'm going to write listed in diagram. The number in the sample space we all know is 8. There's 8 possible outcomes. A, however, excuse me, are only the outcomes that have 2 heads in them. So there's head, head, tail, head, or tail, head, head. That's it, those 3. The number in A, 3. The probability then is 3 and 8. And 3 divided by 8 is about a 37.5% chance. So we know there's a 37.5% chance of flipping exactly 2 heads, not at least, but exactly 2 heads, 3 flips of a coin. Okay? You can use tree diagrams to help you understand questions. We used a tree diagram in yesterday's homework to figure out that Blue Jays example versus the Yankees. That was a really good use of a tree diagram to solve a question like this. Okay, moving on. How about if we need to use, let's say, a permutation in a probability question? So here's example 2. 4 students form a queue, that's a fancy way of saying a lineup, at the school cafeteria. Well, if they're lining up, right off the bat, my alarm bells are ringing. Does that mean that arrangements count? That order matters? Yes, it does. What is the probability that they line up in descending order of height? That means that the first person in line has to be the tallest and the last person has to be the shortest. So if order matters here, then the total number of ways that we could line these 4 students up for lunch at the cafeteria is 4 P4 or 4 factorial ways. 4 factorial is, you guessed it, 24 ways. The total number of outcomes where they are in descending order of height, though, where they have to be in that order specifically, there's only one order that happens in. So the probability of this event, which by the way is NA over NS, NS was the unrestricted 24 ways to line them up. NA is the one way we're looking for when it's restricted to descending order of height. 1 out of 24 is about a 4.17% chance of that happening. So far, so good? You can see how we can use permutations to answer these probability questions. In fact, we use them here to find NS and technically to find NA. Okay. In example 3, Before I get to this answer, you might want to pause the video and try it yourself. I'll read it to you. A committee of 5 people has to be selected from 10 males and 8 females. That's an important word, a committee. If it's a committee of 5 people, do we care how they're ordered? No. The question is, what is the probability that there are exactly 3 males on the committee? We have to make sure there are 3 males on this committee. Okay, so now's a good time to pause the video if you want to try this yourself. And when you're ready, unpause it and you'll see the rest of this answer. Are you back? Okay. The total number of people to choose from. Well, how many people are there to choose from here? 10 plus 8 equals 18 people. So we know that there's 18 to choose from, and we have to make a committee of 5. So unrestricted, NS, the sample space here, is out of 18 people, choose 5 of them. 18 choose 5 is 8,568 ways to do that. And A, if event A is this, where there are exactly 3 males on the committee, well, that's different. That's going to limit our options here. Out of the pool of males, the 10 males, we have to make sure that there are 3 on the committee. So that is 10 males, choose 3 of them. Does order matter? We said no. So it's not a permutation, but a combination. That's only 3 people on the committee. We need 5 people on this committee, so where did the other 2 come from? Well, we must get the other 2 from the 8 females. If there's exactly 3 males, there must be exactly 2 females. And 10 choose 3 multiplied by 8 choose 2 gives me 3,360 ways. Well, if this is the unrestricted total, and this is the NA, the number of ways that this could happen, well, then the probability must be 3,360 divided by 8,568. And that gives me a grand total, or therefore, of approximately 39.22% chance of that happening. I hope you like that question. I do, because that's a really great example of everything we learned over the last 2 units combining together to allow us to calculate that probability. So here we have the probability of exactly 3 males on the committee. What is the probability that the committee will not be comprised of exactly 3 males? Now you're probably wondering, what does that mean? It means that you cannot have 3 males total on the committee. You could have 2, you could have 1, you could have none. You could also have 4 males on the committee. So if the only thing that you're not allowed to have here is this, then we can find out the probability of A complement very easily by saying it's 1 minus the probability of A. And 1 minus that answer gives me about 60.78% chance that it will not be comprised of exactly 3 males. Don't forget, this could include all the cases where there are 0 males, 1 male, 2 males, 4 males, or maybe all 5 males. That's why it's so high. Last example, example number 4. This is another good one too. If you want to stop the video, pause it, try it yourself, see how you do. Read the question carefully, underline important things as you're reading through, and see how you do. And I'll wait for you. When you unpause the video, you should be right back here and we'll start the answer. Are you back? Okay, here we go. We have 2 brothers that enter a race with 5 friends. Well, that means we have 2 plus 5 equals 7 racers total. That's important to know how many racers there are. The racers draw straws to determine the starting positions. Well, if they're starting positions, first, second, third, that means that order matters. Definitely order matters in this question. So I'm not thinking combinations, I'm thinking, you guessed it, permutations. What is the probability that the older brother will start in lane 1? That seems very specific, with his brother right beside him in lane 2. Okay, well, let's start this question by figuring out the number of ways in the sample space, which in this case means we have to arrange these 7 racers. Well, if we're arranging the 7 racers into the 7 starting positions, that means we have 7 permute 7, or 7 factorial ways. 7 factorial is 5,040 ways to do it. That's the unrestricted version. Now we think about the number of ways we could do this if the 2 brothers have to be in lane 1 and lane 2. They can't switch lanes. The older brother has to start in lane 1. Well, if the older brother's in lane 1, let's fix him there. There's one choice for that lane. There's one choice for the second lane as well. But how many ways can I permute the other 5 friends into the last remaining 5 spots? 5 permute 5, which is 5 factorial, and 5 factorial is 120 ways. So now that we know what the restricted and unrestricted versions of this question are, we calculated them, we can now figure out the probability of this event A happening, that the brothers start in lane 1 and lane 2. It is 120 divided by 5,040. Pretty small chance, actually. It's only about a 2.38% chance of that happening. And finally, in example 5, what is the probability that at least 2 students in this class share the same birthday? We have to assume, even though we just went through a leap year, that no students are born on February 29th. So that tells me there's 365 days in a year. And you also need to know how many students are in this class. Now, since I have 2 classes and there's 2 different amounts, we are going to say that in either class there are 25 students. Okay? So that's how I want you to answer this question. I'm going to give you some time to think about it. I won't take it up with you until I get back, but definitely please think about this birthday question, example 5. So with 25 students in our class, let's say, there are 365 days of the year, I want to know what's the probability that at least 2 students in this class share the same birthday. That's it for today. I hope you guys have a great day. You have homework, you can check it out online. And if you have any questions, burning questions, you can always email me. I can't guarantee I'll get back to you right away though. Have a great day, guys. Take care.